All right. All right, so let's do a few more of these. Let's talk about Sysmon. Here you can see a page explaining how Sysmon works, and it is really, really nice. It is so simple. There's a Microsoft official page. There are so few events. And so once you get Sysmon installed, process creation, a process change to file creation time, a network connection, um, driver loaded, image loaded. There's only about 10 or 11 of these events, and they're very simple. And the one we care about is process creation because remember the attacker uploaded an exe and then ran it. So that's going to create a process. So we were here before. We found the name of that exe. If I search on this page for .exe, then I will find, here it is, 3791.exe. So that's the name of the thing. So I want to find the command line that created that process. So I'm going to look at Sysmon events. So I'm going to just clean all this away and turn on some sampling and just search for everything. It didn't, all right, I didn't delete all of it and run. There we go. And still messing with me. I'll put in a star maybe, get it to like knock it off. There we go. There we are. Now I'm finding a bunch of events. That's what I wanted to see. And I wanted to see the source type here. And here's Sysmon, operational, is this source type. So I just want Sysmon events. And again, I'm sampling because I don't, now I want to find the event ID, which is here. And as you see, 1, 2, 3, 5, 7, there aren't that many. I want event type 1, which is process created. And now there aren't very many of them all, only 6. So I'll turn off the sampling to see them all. And now I want to look at the command line to find the correct event. If you go down here, here's command line, and you see there it is executing things of various types, and there really aren't that many of them. So I bet I could probably use one of those tables again. Let's try table. And I guess I'll use time and command line. That should do it. And it's still searching. There we are. Here they come. So I see various things happening here. And one of them is going to launch that executable. So I could hunt through it this way and see all the commands that were executed, but it's probably easier is to just put, I know the name of the thing was 3791.exe. Let's find events that refer to this object, 3791.exe. And there's 5 of them. And if I look at the command line of them, here they are. Here's one launching command, and then this, here's other ones doing it. So there's various ways to look at it. And now if I look in here, Sysmon also gives you the MD5 hash. You'll see it here, hashes. And there's only 3 hashes here, so you can just try until you find the right one, or you can try to understand it. It's a little confusing. So let me get, let's try this. Let's make that table of time, command line, and hashes. See how that looks. All right, so here's various cmd.exe. Here's some hashes. And here's 3791 itself. So now if you forget which one it is, this one here is the thing. It launches a command prompt and then runs that inside it. So I think this hash is actually the hash of CMD, but I'm not sure. I think this is the one you want, but there's a few possibilities. And anyway, it shows you the value of Sysmon. So that's ways to find the actual hash of something that was executed, which is, of course, very useful. So you can take that hash to VirusTotal and see if it's known malware, or use that hash to scan your other boxes to see if they're infected with the same thing, that sort of thing. And now let's look at the ransomware attack. We need the IP address of this desktop system. So we'll just search for this system, search for that name of that system. So let's go up here, delete, just search for events that contain that. and I'll turn on sampling again because there's going to be a lot of them. All right. And now I want to look at the source field. There's a variety of values here, and I want to consider this LDAP is what I want. Lightweight Directory Access Protocol is what Windows domain logins use to log in. So those are the ones I want to examine. And I want to find out what the IP of this thing was on the 24th of August. So there aren't very many. I got to turn off my sampling to see them. And now here's a timeline showing me, here's August 25 and here's August 10. I want to know what happened on August 24. So I think, yeah, from August 24, 7 a.m. to 7 a.m. August 25, if I just click the green bar, it'll give me that time range. Maybe I have to double click it. Yeah, that added this time range. So now I'm getting the 48 events on that day. And I just want to find events and look at their IP addresses. So here I am on August 24 around 11 a.m. And I can see the destination IP here and source IP here. And you can kind of tell just from the pattern. And typically, servers have these low numbers at the end, like 20, and clients have the high numbers at the end, like 100. So this is very much going to be that's going to be the IP address of that client machine on that day. And the point is, this is going to be the source of the ransomware attack. This client machine was infected by USB stick. So we can find that out from the suricata signatures. The suricata detected the server malware. So to start with, we're just going to search for the word server. And I could probably leave this time constraint in, and that would probably be fine, because that's when it happened. So I have 21,000 events. Yep. And now I can look at the source field. All right. And I want the suricata one here, suricata events. See, these other things mention server, but here's the suricata events. There's only 5 of them. And so you can now see them here, the details of these, and you can see there's alert signature, Trojan ransomware check-in. And you, by the way, can see the entire time domain here. Let's make a table of time and alert signature. That makes it easy to see. Once I learn how to do this, this becomes one of my favorite ways to analyze things. An alert signature, if I spelled it right. Yeah, so now, oh, I guess alert signature wasn't the right field. Let me go back. I'm going to put this in my clipboard so it's easy to put back. Let's go back and find it was alert dot signature. That's what I did wrong. Okay. So I'll put this back and put a dot in there instead of an underscore. All right. There. And now I can see, I can sort by time, and I can see exactly what happened here. At 49.24 seconds, or 49 minutes and 24 seconds, it checked in. Then it had some ICMP. Then it did an onion domain lookup at the end. What's going on? This is when it started. It connected the command and control center and said, start encrypting things. That was at 9:49. Then it continued to encrypt things until 10:15. It took 25 minutes to encrypt the files. And now it looked up the ransomware note with the onion domain. So I know exactly the time of the attack here, and I can see the process. And you can answer a lot of things here. For example, I might want to know what fully qualified domain name it sent them to at the end to show the ransom note. And so I'm going to start with suricata. So let's go back to here. Actually, I think that time range is okay. That's when the ransomware happened. So I start with suricata. And then I want to find the alert signature, the onion domain lookup. Those are the ones we saw. With alert signature containing onion domain lookup, well, alert dot signature. Ah, well, I'm a little confused. Signature ID. Time within 1 second. Let me go back to you had the onion domain lookup before. We looked for server. So I think there may be a flaw in my instructions here, but server. We found those 5 events. Okay. By doing source suricata, let me get back to where I was. That was a good place to be. Okay. Now here I had the onion domain lookup stuff. There. Here's the onion domain lookup. Those are the ones I want. See, once you've found them, this is the suricata intrusion detection system detecting a lookup, but it does not store what the lookup was for some reason. To find that, you have to look at DNS events. And what you can do is you can easily restrict the time to within 1 second. See, these 2 lookups are at exactly the same time. This is the time when the intrusion detection system detected that something is looking on the Tor network, which is suspicious. So I can just restrict the time to within 1 second of this event easily by clicking on it. I apply it. Now I've got a 2-second window of time, and now I can clear off all the rest of this and look at all the events in that time. Because it's only a 2-second time range, there won't be too many of them. And it looks like I'm going to have to put a star in here to get it to run. All right. There, now I have 4,000 events, but I want to see the DNS events. So I can go to Stream DNS. And there's only 16 DNS lookups in that 2-second time period. And I can look in the query field to see what was being resolved at this time. And there were only 4 things looked up. 3 of them are obviously harmless, Bing and Microsoft. This is the one that's the Cerber ransomware. That's the domain, which is an unusual structure for an onion domain, but that's the one. That's the domain that was used to look up the ransom note. So, all right. And now I can find, all right, so that's the fully qualified domain name it looked up. Now I can see what's the first suspicious domain visited by these guys by we 1814 desk. So on 24 August 2016, let's restrict the time to that day. So I can do date range 24 and 2401. This is right. I'm going to apply that. That's the date range. Now I'm going to find the suricata events on this day. Let's get rid of this other stuff and see all the events on that day. I'll turn on sampling again because there's going to be a lot of them. All right, now I want the suricata events. So I go to source type, and there they are, suricata. Okay, and there are 85,000 of them. I'm sampling. Now I look at source IP, and I want to know domains visited by this guy's address ending in 100. That's the machine that was the source of the infection. Now examine the event type field and find HTTP web load. These are the web pages loaded on the day of interest by the machine that I suspect to be the source of the infection. I'm going to turn off my sampling and look at them all. Now there are 38 such events. And now look at the host names down here, and you'll see HTTP host name. There are 10 of them. And again, 10 of them are obviously harmless, like Microsoft, Acronis. Here's an IP address that might be funny, but here's one that really looks funny, solidarityproximity.org. And that's the malicious domain they went to do something suspicious, like get infected or something. That's the suspicious domain visited at that time. And I think the last one I'm going to do is the VB script, which is pretty amazing. If there was the ransomware actually runs a Visual Basic script. And so the easiest way to find it, it has both a Visual Basic script and an exe in it, in the event. So I can look for .vbs and .exe. And I could change the time range, but it happened on this day. This is the day of the ransomware attack. So that should do it. I find 10 of them. I think it'd be 16 if I used all time, but I'm going to use the body field. And here you can see, here's a bunch of junk here. A process has been created. Notice this. This is the script. See this do while W script N sub? That is the actual VBS script that did the ransomware infection. You can see the whole script here. And so it is pretty amazing. You can read the whole script. You can even see how it's going to create a random variable and use it for a random name and so on. So you can pretty quickly find the exact script and all the source code that ran it stored here. So it's pretty nice. Anyway, there's more you can do. If you go through these, you can actually find the name of the USB stick that was plugged in to infect the machine and so on. But you get the idea. This is why people love Splunk for threat hunting. After you learn how to use it, it's very helpful to track down what happened. So I'm going to stop this recording.